Start.
Hello everyone, my name is Eason. Today I'm going to introduce operational modeling of Bigeye spatial dynamics in the Indonesian region. And the main target is Bigeye tuna. It's a major species on the global tuna market, including Egypt and Lehodey. And it has a wide depth of action. The adult one can dive usually deeper than 600 meter depth, and they usually caught by using subsurface long-line fish skills. Many ways to catch them, and I have tell the three common methods. For example, the first one is long-line fishing. Long-line fishing is, as a name says, natural long-line and mean-line behind a boat. And the second is percent fishing. And it usually used in open ocean to catch single species with a big net. And the third is fishing aggregating device, FADS. It's man-made and usually floating wooden structure with hanging nets and catch fish. And we can see the catch of Bigeye by fishing in the Indian and Pacific Ocean. And we can see the mean fishing ground is concentrated. And the major method to catch the Bigeye in the Indian Ocean is long-line fishing. Second is the percent. While the distribution of Bigeye popular event is climate-driven environmental variability, and this is a powerful 1997 to 1998 El Nino event in I.O., causing a strong seawater anomaly and substantial coastal width in the west coast, and later primary production anomaly high coast. And the result is very Bigeye tuna. We can see the annual event in September 2015 and the La Nina event in September 2016. Then the seawater temperature, you can see a strong cold anomaly in southern Indonesian region compared to the La Nina phase in 2016. The primary production of these two pictures. The picture shows there is a productive coastal aquarium south of Java and Sumatra of the Banda Sea. 1 year later, La Nina event will appear, and the situation is outside of the 2000. And the Bigeye larvae density. In time, and survive completely reversed from highly favorable in September 2015 to a very unfavorable in 2016. And we can see the picture. Its total spatial include catch of Bigeye tuna in the Pacific Ocean. The line is nominal catch data and the bar is georeference catch data. And we can see the georeference data and match the total catch by many countries. But the situation in the Indo Ocean is not very okay. 1/3 of the total Bigeye catch without any information, and we can see a clear gap on the data. And that is the new problem of the paper. Scientists want to display. And this is the model we use in research. C patterns, spatial ecosystem and production and population dynamic model. And why use this model? Because overfishing in Indian Ocean, illegal, unregulated, or unreported also means IUU. And it provides sustainable management of marine resources. And this is the new management tools taking account both the fishing care and environment variability. And why is the model framework? One, definition of temporal and spatial distribution of extractive predator populations. Second is the total catch and the size frequency of catch by fishing fleet. And the third is prediction of the spawn habitat. And next is using habitat indices, movement and growth and materiality to estimate dynamic of fishing population. Now, scientists use parameter optimization based on the data simulation and optimization achieved in the Pacific Ocean run in the Indian Ocean with the same way. And satellite observation and real-time data to form a population from real-time indication. We can see the spawning habitat of Bigeye tuna, which we found in the Pacific Ocean. And we can see the temperature is 26.8 degrees. Is pretty most favorable temperature to Bigeye tuna larvae. And the age at 10, we can see the 9 degrees, all these larvae can live. We can see a growth and maturity of Bigeye tuna found in the ocean. The minimum coefficient is 0.02, and after 10 years, growth increased to 0.1. And the precision of Bigeye tuna starts with and without downscaling. The downscaling method is capable information from large scale, long resolution to small scale, high resolution. Usually used in climatology. And we can see the red circle. The red circle on the picture shows they have low biomass here. And why? Because this situation. Because of south equator currents. And we also see these two circles. This difference is due to the strong The circle on the picture shows that there are large total masses in the Arctic Sea compared to the equator and southern of Indian Sea. Then the mean situation is spawning ground is more favorable and low level of catch here. And this next we can see the place here close to equator and have medium quantity boundaries. And scientists also provide great explanation for this. They use another high resolution method to divide two non-boundary quantities. And we can see the semi-closely where the environment is more favorable for Bigeye growth. And as a result, it's a successful attempt with the experiment in this model. It's a production of global and regional focus of spatial dynamic of tuna species, and provide accurate information on the position of fish activity. And most important one is allowing the manager and fishermen to identify where fish area are at risk to catch high amount of immature Bigeye tuna. And there is something we can improve continuous upgrade the historic fishing data, and then use of these new type of methods. And the data collected with more detail and more refined. 1/3 of the total catch mission data need to be included in some way in the future. And this is testing different ocean model data. Diversity of diversity of data may have possible to estimate.
8 minutes left. 8 seconds left.
The level of IUU when catching the same spatial areas. And this is my explanation. Thank you.
Chris. Ray. Ray. Alex. Oh. Okay, Chris.
So, how did they count in those tuna? Like, how did they collect those data of tuna?
From many associations, like IOTC, Indian Ocean Tuna Association, and big data of the kind, like currents and climate change data.
Ray.
How do they collect the biomass data?
Fishbowl and use its computer and collect data, and scientists go and as these data go collect.
Alex.
They will turn the dog and 6. 30 maybe 30 slide. 30 slide. Yeah, that's good. That's yeah. And what's the name about the carbon?
Provide density of Darwin is a collision.
So it is the tuna density.
Yes, tuna larvae density. It's too small to count.
Can you explain more about the figure? Download. 14, page 14. What do you mean the 90?
It's a minimum of Bigeye can live in the ocean. At an age of 10. Yes.
Volunteer question, any? Soil, sand, and sky. Soil.
I want to ask how to monitor the dynamic of greenhouse tuna population in different seasons.
Because of this species high migrating species and their habitat also around the world. So we want to collect more data about this and let the data is more clear to analyze this situation.
Sam.
It's like left figure, the y-axis is the number of life. However, I'm confused that it means the SSE is 26.8 means only 0.05 tuna no, yeah, the y-axis. You say it means the number of all. I think the percentage
Oh, don't mention on the paper, so I just confused these.
Okay. Sky.
I want to know how many parameters you should include to the models and what kind of them.
Near 50 years of data, many of data, so it's complicated to use this model because the data is very much.
She's not asking about data. She's asking about parameters.
So what kind of parameters?
About physical face, so I can it.
Okay, my turn. So this is talk about modeling. So I wonder if you have asked somebody about the basic ideas about modeling. Okay, some teacher, which means you have asked. So I think the main problem of this talk is the presentation. I think the format is good. So you see it's very colorful, the headers are good, and also the sentences are short. But in terms of content, there's space for improvement. So I think the first thing about, I think introduction part is okay, but first of all, you need to, no, not this one. You need to tell us what do you want to, what did the authors want to achieve by the use of this model? What's their question? Here, just introduce this model, but they want to use this model to achieve a purpose. What is that purpose? You didn't say that. So that's the first thing. And then the next is you talk about this, but in my opinion, this is all too abstract, 抽象. Okay. I think an easy way to tell people what you have done is like a Sky's question. You tell people what kind of parameters did you use did they use in their model? And I think actually there's a table. You see, these are actually the parameters. And of course, you don't need to tell the audience all the details. I think you just need to tell them, they include temperature, they include something, 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 the general category. You don't need to read through these lists, which might be 50 types, 50 parameters. So you just need to tell us roughly what did they include to do their model, to work on their model. And then when present, so I think these are also abstract. It's even if you introduce, after your introduction, we still have no idea what the model is about. So I think this can be skipped. All right, and then here you really need to distinguish when presenting a modeling paper. You need to say clearly if this is based on observation or model. Is this based on observation or model?
Yeah, observation.
And how about this?
And also, both of them.
Both observation, and how about this?
The data is Pacific Ocean, and they use it in Indian Ocean, so it may be observation.
You need to clarify that, especially, usually if it's observation. I think most times scientists would tend to plot the raw data here. But here you just see one curve. This really makes me wonder what's the nature of this data. You need to tell us, because observation is to feed the model, right? And then the model will produce some prediction, and the prediction can be then used to fit other observations. So it's a cycle. So you need to really tell us what's this, and what's the purpose of the data here. Are they the data used to feed the model, to train the model? You need to tell us that. Okay, then about this, I would say now it's about the modeling results. The problem is there are some keywords that you did not tell us. What's downscaling here? You can explain next time. You need to explain some keywords, because it seems like there is a difference between with and without. And what's the meaning of downscaling? So that you see the difference between these two modeling results. And I suggest that for each slide you tell us this is based on observation or this is based on modeling. You have to say clearly. And then there's another keyword. Where's that? Okay, here is another keyword you need to explain. Why do they always add bet and bet? What do you mean by bet, or what do they mean by bet? You need to explain that, because that really makes me wonder, is it based on some probability model, or is it based on observation? So that's the key issue when present a modeling paper. You distinguish clearly this is observation and this is modeling. And I think the data presentation here is a little bit not clear. It's not very clear. What's the key message of these beautiful pictures? What's the key message here? So, for example, here you say, spawning grounds more favorable and low levels of catch. This is number of individual per square meter, right? Then how do you say low levels of catch? What's that? Why can you say that? I mean, it is unclear to me how you, based on, this is a modeling result, and how do you draw this conclusion based on these results? This is not clear. So that's something you can improve. You need to tell us this logical link between your data and your interpretation. This is the interpretation. Okay, and then there's some pronunciation issue, but I will tell you, or I will write on the YouTube comments. Okay. And also when you introduce this, you need to say clearly this is only this unit. This doesn't really tell us what they are. This is just unit. So you need to tell us what's this. Is it adult or a larvae or biomass? I don't think this is biomass. So you need to tell us clearly for each of the image with a color bar. Okay, so let's thank Eason.